So if you look at problem 2D on the buffer problem set, you realize that in problem 1D, which you definitely should have done before this problem, you essentially have a buffer system. You have propanoic acid and the conjugate base salt, sodium propanoate. So my expectation is when I add the acid, it's not actually going to change the pH all that much if this is a good buffer. So if I look at this, I know I'm adding HCl, which is really H+. Well, which part of my buffer is that going to react with? That's an acid, so I know it's going to react with the base part. So in my buffer, the part it will react with is the propanoate ion. And it's not in equilibrium, it's actually reacting. I have this reaction, and it's proceeding to the right. Remember, the assumption in a buffer system is that all the strong acid or base you add will react unless there's too many moles and it exceeds the buffer capacity, which we will check on. So I know when I do that, I'm going to make propanoic acid, which happens to be the conjugate acid of my base here. So if I look at this, it's not so much equilibrium as this E stands for the end after this reaction has taken place. So if I look at what I first had, well, I'm adding 0.02 moles of HCl in a liter. So again, I have 0.02 molar. Check problem 2A if you need to figure out how to solve for that concentration. If I look at my buffer system, I have 0.1 molar of each of these. And the assumption is I'm going to get rid of all this HCl if at all possible. Well, if I assume that I do that, this will be around 0 when it ends. And is this possible? So this is what I mean by checking the buffer capacity. Do I have enough of this base to react with the HCl I gave? So if I do that, I'm going to have about 0.08 molar. Well, that's fine. As long as I don't have a negative number, I'm not exceeding the buffer capacity. And what that means is this will be a plus 0.02. So I'd have 0.12 molar. So now these are the concentrations I have once I've added the acid and it's reacted. And now my system is going to reestablish equilibrium. So now I need to actually do a regular equilibrium. So if I look at this, same thing as normal, HC3H5O2. You can put in water if you want or do it the other way. It really doesn't matter. Just keep in mind that H3O plus and H plus mean the same thing. So I set up equilibrium, and notice I have a double arrow here to show you equilibrium because this is establishing equilibrium. Here, this straight arrow going just to the right tells me that it's reacting and going that way. Two different things. So if I look at this, okay, my initial concentration of propanoic acid is 0.12 molar. Cross out H2O. My initial concentration of H3O plus, keep in mind that really is H plus, is 0. And propanoate, I have 0.08 molar. So now I'm going to do my X's. I'm assuming it's going to go to the right since I have more acid and I can't use up any H3O plus I don't have. That would be silly. So minus X plus X plus X. This would be 0.12 minus X. X and 0.08 plus X. Same thing as always, Ka. So my Ka, you would have to go back to the first problem to find the actual number for Ka, which you can see at the top of my paper right here is 1.3 times 10 to the negative 5. And when I plug that in, I get top times bottom, so the products over the reactants, X times 0.08 plus X and 0.12 minus X. Again, I can get rid of these plus and minus X's because my change is going to be not substantial compared to how